Hi, and welcome to Allen High School's discussion of chemistry at the pre-IP or honors 10th grade level. We're talking about states of matter. We've already talked about chemical physical changes. Now we're moving into some of our key physical changes, and those are phase changes, changes of state. But before we do that, before we start distinguishing the names and reviewing those, we need to make a clear distinction between intramolecular bonding and intermolecular forces. Now, we're going to be learning a little bit later on about covalent molecules. And just to give you an idea, covalent molecules are like sugar. This is maybe a glucose or a galactose or something like that, C6H12O6. Carbon dioxide would be another example. Now, to hold those together in a solid, or liquid, we have to have a force of attraction. So in carbon dioxide, we have the bonds that hold the carbon and the oxygen together, and those would be, that actually represents a double bond. We'll learn more about that, but a line, I want you to notice, is between the two atoms. These are intramolecular forces. Now, to stay together in a solid, we have to have some sort of force of attraction between these molecules. And so if I had another molecule, I would form, or to get it to be the solid, a force of attraction between the molecules that hold them together in the solid state. The solid state for this would be dry ice. And those forces between molecules are called intermolecular forces. So we have intramolecular within the molecule, and we have intermolecular between two molecules. Now, in terms of phase changes, we are not changing the nature of the substance. A phase change is a physical change, not a chemical. And if it's a physical change, we do not break bonds or form new bonds. So what we're dealing with are intermolecular forces. So in this picture with water, this is the bond in water. If we have water as a liquid with two H's and an O, we're still going to have two H's and an O when we form the gaseous phase. We are not breaking those intramolecular forces. Instead, we're breaking the forces of attraction between molecules of water, between discrete molecules. And those are the forces that hold things together as a solid or a liquid. So, we're going to talk a lot more about these in a later unit. We will distinguish the different types. But for now, I need you to know just what they are, because they impact the properties. Structure determines function. So those intermolecular forces are going to be critical in the properties of the different phases of matter. So if we look at a solid, the molecules are very close. If we look at a liquid, the intermolecular forces are breaking and weakening. In the solid, they're very strong and hold it together tightly. By the time you get to the gas phase, the intermolecular forces have been broken. Solids have a definite shape, definite volume. Liquids take the shape of the container and have a definite volume. Gases take the shape of the container and the volume of the container. Now, some of these properties are fluidity, the ability to flow or the resistance to flow. Solids are very restricted. Liquids are limited because they still have intermolecular forces holding them together. Gases have no forces of attraction. They're free to move and go wherever they want. Density is how tightly packed the molecules are. We studied that earlier. Solids typically have a high density. There is an exception, and that exception is water. In water, the density of the solid is actually less than the density of the liquid due to the crystal structure. But in general, density of the solid is greater than density of the liquid is greater than the density of the gas. A couple more properties here. We have compressibility, the ability to smash down and force it to take less space. Solids are not compressible. Liquids are teeny tiny bit. Gases are easily compressible. And as you can imagine, there's like a gazillion different multiple choice questions we can ask on this. Expansion, the ability to expand and increase into space occupied. Solids do not expand. Liquids will expand very slightly with an increase in temperature. Gases expand tremendously with temperature. Diffusion, if I sprayed perfume in the room, eventually you would smell that perfume or air freshener because gases move amongst one another very quickly. Liquids diffuse fairly easily. Like if you're at a concert and it's not a big crowd, you can move around pretty easily. But if it's a really popular concert, you get up to the front and you can hardly move. The people are packed in so tightly. So diffusion is very slow. There is a fourth state of matter called a plasma. We won't talk about it too much in chemistry. It delves a little bit more into physics. It's an ionized gas. It's gases that have positive or negative charges, and actually they make small plasmas when they make your computer chips. Plasma reactors are used, and they're pretty cool. So I wish we had more time to talk about that, but if you get a chance to take solid state chemistry, you would talk about that. Okay, in the next video, we'll review our phase changes. So until then, this is signing off.